these batteries last an average of about 32 hours. And when I say about, some last more, some last less. Well, about how much do they last, more or less? Well, that's where we get the standard deviation. They last about somewhere between 32 hours plus or minus 3 hours. Now, that's for each battery. Well, what if we did something where we say, well, let's take a sample of 100 batteries and just look at the average of how much they're off by as a group. Okay, well, the average will still be 32 hours because it's an unbiased estimator. But the new standard deviation, how do we figure that out? Well, if you remember, you take the old standard deviation and you divide it by the square root of your sample size. So we're going to say that it is, what was it? 3 was our old standard deviation divided by the square root of 100. So that is 3 divided by 10, which is 0.3. So that's where this comes from, in case you were like, where do they get that number from? Well, now, what if we increase the sample size to 400? Well, why don't we just do it, okay? So the old standard deviation was 3, and we say the square root of 400 is 20. So 3 divided by 20, and you would get a value of 0.15, which makes sense to me because the larger the sample size, the smaller your standard deviation is going to be. You're going to get more accurate information. Now, how do these two compare? Well, 0.15 is half as big as 0.3, which is choice B. There we go. Let's do the next one. Okay, here's the situation. They're going to test this reading program that claims that it increases people's comprehension. They have 15 people, and it's basically kind of a before and after situation. Now, they're going to take a test, and then they're going to do the reading program and take another test, and they're going to see if their comprehension improves. Now, it's the same person, you doing the before and the after, not two different groups. So that's a matched pairs test. Okay, now, how do we figure this out? Well, think of it this way. For the matched pairs, remember, let's just say we have before, right? They take a test before they do the program. We would put that into list 1. And then we might say, well, we're going to put all the afters into list 2. Okay? And then we would subtract. We would subtract these, and you would put that into list 3. That is our results. Now, we would only work with list 3. Now, maybe you would say the score is higher after, right? The before and after. So if the after score is higher, if you subtract, you would look for a negative result. But you're just going to just use this list 3 for your test. It's definitely not a chi-square, okay? And also, it's not a proportion either. The score isn't like, if they get a 70%, that might not mean that they got 70% of the test correct. So it's not a z-test either. So now we're down to the t-test. And we're just going to use this one list. So it's a one sample t-test. There it is. Seems like they always have a question like this. We've got to remember way back at the beginning of the year about outliers and what do they affect. So think of it this way. Let's just say that you have a list of numbers listed from lowest to highest, and the highest number was 80. Well, let's just say we change that 80 to 800. So what would be changed if we did that? Well, the middle number is still going to be the middle number. We changed 80 to 800, we still have the same number of numbers. So the median is going to stay the same. So we should take a closer, well, at least look at those. Now, what about the mean, the average? Well, if we change it from 80 to 800, the average is definitely going to be higher. So that's out. The range. Well, the range is the lowest number minus the highest number. Well, if we change it from 80 to 800, the range is definitely going to change. So that's out, which means C is out. And now the IQR, now think of it this way. The lower quartile, well, quartile 1 and quartile 3. So quartile 1 is really the median of the lower half of the numbers. And quartile 3 is the median of the upper half of the numbers. So that's not going to change. So it's still kind of like a median, the IQR. So that won't change, and that means that D is our answer. And by the way, standard deviation will be affected by an outlier like that. So there's that answer. Okay, so you have this bottle of medication, right? Now, if it was sold for $10.48, it had the 90th percentile, meaning only 10% of the stores charge more than that. And if it's at $8.61, it's on the lower end, only 20% of the stores charge less. Now we're trying to figure out the average price of this medication. Now, let's take a look at how we would do this. So, let's see. What we really need to do is that inverse norm, right? Inverse norm for 90%, and what is the critical value for that? How many standard deviations above the average is this price at 90? Okay, what's that distance in standard deviations? Well, turns out it's 1.28. Okay, so at 90, it's 1.28 standard deviations above the middle. And then what about the 20%? This price, how far below in standard deviations is that? Kind of like a z-score, right? So inverse norm, and below it would be negative 0.84. Okay, well, what are we going to do with that? Well, let's see. The price, right, is 10.48. Okay. How do we get that price? Well, it's the average price plus 1.28 times the standard deviation. Okay? And how do we get the other price of 8.61? Well, 8.61 is equal to that average price plus negative 0.84 times the standard deviation. That's how we get that price. Well, look at this. You would have to go back to, say, Algebra 2 and say, well, what if we solve these two equations? In other words, maybe multiply everything by a negative, right? That turns that positive, which gets rid of those x's, doesn't it? Okay, so what do we get for that? So I'm adding these up. These go away. I add this up. This is what my result was. I added these together. That multiplying through by negative made that a positive, so we get this. And then to solve for this variable, which is the standard deviation, divide both sides by 2.12. And you get the standard deviation, we solve that, is equal to 0.88 approximately. Okay, so there is the standard deviation, which is, dang, we're still down to two choices, right? So what do we do with that? Well, if you remember from way back, you would take this number, right, and plug it back into one of these equations, right? And now you get a number for this part and for this part, and then subtract that from over there, and you get what x is. Again, that's just solving a system of equations, and like you did in Algebra 2. And it turns out that when you plug that in, you get choice A. Okay, that was a very challenging question. So don't feel bad even if you were like, what are you even talking about? So don't worry about it. We're going to miss a few. So, but if you followed along, that's awesome. Okay, let's go to the next one. Okay, so let's just think about this. This is a matched pairs design. They teach these people a new method of assembling these products, and they just see, do they do better? Now, the assumption is that there's no change in the new method and the old method. So you would put this into L1 and this one into L2, maybe subtract them, and you put the result into L3. And so what you say is, well, we observed an average of, well, whatever we observed, right? Minus what we expected, which would be 0, divided by the new standard deviation. That's how we do a z-score. That's kind of what a test statistic is the z-score, except this is a t-distribution, okay, for matched pairs. So, because we're going to take a look at the average. Now, after we do all this stuff, right, we get our test statistic, we see, does it fit into that alpha level of 0.05? Okay, so I just thought about it this way. I say, well, what number does get us in there? Well, we'll do the reverse. We're going to do the inverse t in the calculator. And I'm going to say, well, the area, right, is 95%, right? Because if we're above 95%, that puts us into our alpha level, okay? Remember, it kind of looks like this, and we would be there. This is at our 95%. This is our alpha level of, this is 0.05. So what number gets us into this area there? And then the degrees of freedom is 8 because there were 9 people participating. Put that in the calculator, and it spits out a value of 1.859. So any number that's bigger than that. And I think it keeps going. So if we rounding error, it looks like it is choice D. If we had a test statistic that was that size or bigger, we would reject the null hypothesis.